Good morning, and welcome to today's webcast, Find Business Value with AI and Machine Learning. Before we begin, I'm going to play a brief housekeeping video.
Welcome, and thank you for viewing our webcast series. Before we begin, please keep the following in mind. You can customize how you view our presentation and interact with the presenter. For better viewing, close all other applications and turn up your speaker volume. You can adjust window size and placement or enter full screen mode using the controls at the top right of the window or dragging the bottom right-hand corner to resize. At the bottom of your screen, you'll see a series of icons that relate to a different aspect of our session. You can download a PDF of today's slides from the Slide Deck and Handouts widget. You can ask questions by typing in the Q&A window and clicking Submit. We'll do our best to answer all questions or follow up via email. If you experience technical difficulty, refresh your browser by hitting the F5 key. This presentation is not legal, investment, or accounting advice. We encourage you to seek the counsel of a professional service provider to apply this content to your specific circumstances.
And with that, I'll turn it over to Matt McKittrick to get us started.
Hello, everyone. Thank you for joining us today to discuss machine learning and AI solutions and how they can boost the performance of your business. We're pretty excited about this topic. Just a quick introduction. My name is Matt McKittrick. I'm a partner here at Moss Adams. I've been working on data analytics, software solutions, and development, and over the last decade or so, AI-related solutions to help our clients achieve competitive advantages. And pretty excited to be here today. I'm going to turn over to Jesus.
Thank you, Matt. Thank you everyone for joining us. My name is Jesus Renteria. I'm a manager here at Moss Adams, and my specialty is in equity compensation. I've been in the industry since 2016, but I've been in software with equity compensation regarding equity compensation systems since 2019. I've spent the last 6 years or so working on the different solutions and around equity compensation, how to apply different technologies to them. And with that, I'll pass it over to Austin.
Great. Thank you, Jesus. I've been with Moss Adams for about 3 years now. I'm a senior data scientist here. So throughout this presentation, I'll be kind of the technical resource and guiding through some of the more technical details that we'll talk about, and hopefully keep it broad enough to where I'm not going over everyone's heads. So great.
Great, I'll take this slide. So just a quick background. Probably if you landed here, you probably know a lot about Moss Adams. And thank you for joining us again. Within our group, we are about 250 professionals that focus on strategy, technology, and operations. I work on a subgroup within this team that is doing a lot of software development and emerging technology focus. We have software development, data scientists, quality assurance engineers, and business analysts on our team. And we have been focused mostly in 2 industry groups, healthcare and manufacturing consumer products and technology, 3, I suppose. And but I think the topics that we will be talking about today and some of the use cases we'll bring up are relevant for all of the industries, the 30 plus industries that Moss Adams serves. Anyway, we'll move on to the next topic and go into our goals and learning objectives. Hopefully, when you were invited to this, you saw that it's about machine learning. We do want to focus in a little bit on how it's different than the super hot topic of generative AI. It's been fun to watch how generative AI has stoked the fire of AI in general, and obviously the tools like ChatGPT have been mind-blowing in their power and capabilities. And what we're going to focus on today a lot is more about the origination of things before generative AI, like machine learning. And so we'll be differentiating on that to level set. But we do, just so you know, we have quite a focus on the generative AI topics. And in the follow-on email, we'll make sure we link to our additional focus on generative AI that you'd like to follow up in that area. We will be showing how machine learning, different types of machine learning. So we are going to give you a full background here and try and level set. I think that'll be very relevant for people, and the different types of machine learning. We will then turn it to business problem sets and how certain types of business problem sets are very ready for AI and how it can be used within AI and some that are not. So hopefully that'll and then we have a polling question that'll be coming to you about within your own business, how AI applications may be relevant. And you've probably been thinking about that if you're joining this call, but hopefully we'll help bring some of that to bear. And then finally, we want to bring up that there are other considerations when implementing AI and machine learning, and as we all know, it can have its challenges. So we'll bring those up, and especially considerations around investment. Go to the next slide, which is really just the agenda summarizing how we're going to do this. I really like this, the third section, which is focused on examples in the healthcare space. We've got a deep dive into fraud or unusual claims and claims auditing with healthcare claims that I think is very relevant for a machine learning example. And Jesus will be talking about our equity space in the HR world, where we're trying to use machine learning to detect outliers and actually prevent errors from happening, which can be quite costly. So I have some really good hands-on examples for you all to see, and then we'll wrap it up with some of the business considerations as you embark on your own journey. So we'll now go to our first polling question. We only have two, but this is just a fun question for us to understand how familiar you are with AI. I'm sure most of you would not answer A or B, but we'll see, and we'll give a few minutes here for you to click and test if this polling question system works. I am kind of interested in how many people are pros. Let's see, and I just thought I'd share a quick anecdote. When I started investigating AI tools about half a decade ago or so, as they were emerging, and there are lots of third-party platforms that are out there, it was kind of fun. We got involved with a trucking company that rebuilt trucks, and they were interested in using machine learning to identify what trucks they should buy. And there are thousands of trucks available in the market. They were in the business of rehabilitating the trucks, and they wanted to buy the trucks that are most likely to have the highest resale value, and they would want to achieve a competitive advantage with AI. So they had these buyers who would scour the for sale trucks out there, and they asked if AI could do something similar. And so we trained the AI with their prior procurement processes and what types of trucks they bought. They had 50 or so fields between four-wheel drive and dump truck and that sort of thing, the type of fit on the truck and the quality of the truck. And we loaded those into AI engine that then was able to predict whether the truck should be purchased or not based on what was outstanding. And so the idea was to have that truck be, that buyer would be a fourth buyer. The AI would be a fourth buyer. So I think the point here is that AI can be quite an augmenter to a business. And what we saw in the testing, and it was only a very small proof of concept project, but in the testing, the buyer, the AI buyer, had the level of experience right off the bat of someone with 5 years of experience buying used trucks. So it really impressed me that these tools do work when implemented effectively and can be game changers and augmenters to a process. And so rather than having replacing humans, they augment them. And so this was what the AI identified was a truck to buy, and it was reviewed as part of a purchasing board, and it was valuable. So let's go and see what responses we've got so far. Good. So we do have some hands-on experience. Okay, over half, not really heard of it. So good. I think this would be a perfect webcast for all of you, and hopefully by the end of it, you'll feel like you've learned something and hopefully have some ideas on how AI can be relevant for your business. I'm going to turn it over to Austin.
Yeah, thank you, Matt. So now that we've kind of got a base level understanding of where we are maybe all starting at, I'm going to go over a brief introduction of what is machine learning. We've probably heard the terms machine learning and AI before, but kind of we really just wanted to start here with kind of establishing what some of the common terms are. So in the broadest space, we have artificial intelligence, or AI as it's more commonly referred to. And that's kind of an umbrella term that kind of encompasses anything and everything that revolves around computers and making decisions. Underneath that, we've got machine learning, which is kind of a smaller subset of taking certain types of data and analyzing them in ways that are usually not able to be done manually. And then another subset under that is generative AI, which is something maybe more of you are more familiar with in recent years. And that's some examples of that are ChatGPT, DALL-E, which is an image generation service. So machine learning is more focused on clustering, forecasting, and classification, whereas generative AI is more on some tools like ChatGPT. So kind of diving into some of the differences between machine learning and generative AI, we wanted to kind of just highlight this just to kind of, again, level set some of the information that might be out there. Machine learning most commonly works purely with tabular data. So something you might be familiar with are CSV files, Excel, certain database exports, anything that's really in a row and column format. That's really going to tailor itself most commonly to machine learning. And then generative AI is going to be more common with text-based inputs or image-based inputs, where you're giving it some input criteria, and then it runs through a model and it'll give you some output. So similar to what you'd expect ChatGPT to do, that's kind of where that side of things comes from. So again, since we wanted to focus a little bit more on the machine learning, I wanted to dive a little bit deeper into that. Machine learning can kind of be broken down into a couple different categories. They're called supervised and unsupervised learning. Supervised learning is probably what you think of as most common. It's taking historical data and using that in order to build a model that can predict on future data. So, one example is, you might have, and we'll talk a little bit more about this use case in a little bit, but when you're dealing with fraud, you might have examples in the past where I know over 1,000 records or something, I know that 100 of them have some instance of fraud or some instance of an error. We can use that historical data in order to train a model that allows us to then predict on those records for future records that come in. So it's really about taking historical data and then using it in order to build a model to predict on future data. The difference between that and unsupervised machine learning is with unsupervised learning, you're more about clustering similar data together. So again, if you think of like a tabular data set or a CSV or Excel file, it's really all about what can we find out, or what information can we find out based solely on this data that we're looking at. It's less about like past data and future data, and more so about trying to figure out like maybe like what are the if we're looking at customer data, what types of customers exist for our business, kind of doing some customer segmentation. So kind of clustering can kind of be more so done for that, and then also things like anomaly detection and maybe market research to try and understand certain data sets, whereas this more supervised machine learning is more based on classification and regression, which is just doing forecasting and analyzing how things will act in the future. So moving forward here, the little joke that I wanted to play here is that generative AI use cases, one of our internal tools that's kind of our internal version of ChatGPT, I gave it the question, give business use cases that could be classified for each of the following: clustering, classification, and regression. And you can see here those examples were pulled directly from this and put into the previous slide. So again, some generative AI use cases can help with PowerPoint presentations and stuff, writing emails, and asking questions of internal company documents, etc. So many of you are probably familiar with ChatGPT and its uses, but I thought that I'd just kind of show that a little bit here as well. So moving forward, I'm going to pass it over to Jesus, and he's going to talk about what some suitable indicators are for AI projects.
Thank you, Austin. So I'm going to talk about what are the kind of key triggers that you think, hey, AI might be a good candidate to make my life a little bit easier when I'm doing this. So keep in mind that there is some overlap between some of the indicators, and they're industry agnostic. So regardless of what your line of work is, there's a chance that AI could really help augment some of your processes and make them more efficient. So the first one is the volume of the data you're working with. So computers are very good at going through data very quickly, and when you're throwing AI tools into the mix, now you have ways to go through all this data, find patterns, and have the computer make a decision based on the data it sees. So some examples of this are something like social media posts. Like this is the classic, hey, Facebook can show you this ad based on your preferences. And that's all, it's gathering a ton of data based on your clicks, and based on that, it's making a decision as to what ads to show you. It's more specific for us in the HR space if you're working with multiple like Excel files. AI can go through those for you, extract the important parts, and then analyze them for you. So instead of having one person work on these 3 Excel sheets for hours, you can run an algorithm that will do all that for you. It's much more efficient once you get that in place. Next, if a process is time consuming, again, that kind of goes hand in hand with volume. If there's a lot of volume of data, you're going to spend a lot of time going through it. But sometimes data is just complex as well. I know for us in the equity comp space, we deal with multiple files in different formats with different interpretations of the same data. So you can use machine learning algorithms to standardize some of these reports, extract what's needed, again, make decisions based on those. So yeah, there's a potential that it'll reduce manual data entry. In the manufacturing space, where you have a machine producing millions of outputs of whatever component, machine learning has shown a lot of success in predicting when the machine is going to break down. So you can create a model that can indicate when maintenance is required. So you can go in there and have that maintenance done before a machine breaks down and you're at a stopping point in your production. And next is price optimization. So the example there is there's 2 competing, when it comes to prices, there's 2 competing parties. It's the consumer and the business itself. Machine learning models can help. So both of these, you meet the needs for both of these products, both of these parties. So consumers want the best bang for their buck, and companies have goals to meet, and they want to, maximize revenue. So machine learning can help find that middle ground by looking into a lot of these insights for both the consumer and the company, and make decisions based on the best interests of both. All right. So moving on, repetitive tasks. These are tasks that you can do multiple times a day, or they're done on a regular cadence. You can write machine learning algorithms to, again, grab the data from whatever sources, take a look at it, and then just spit out what a human needs to look at. So the classic example here is email filtering. And it's a little bit goes beyond like a spam filter, although the spam filter is also kind of an example of this, but it could be broken down even more into hey, you need to look at emails based on level of importance because of the sender and the content of the email. You can throw a bunch of different variables into it. And it's a little bit more of a sophisticated version of like Outlook rules. Next, machine learning can be used to customer segmentation. So this is like the clustering classification that Austin mentioned. You get these spreadsheets with a ton of customer data. Machine learning can help you find patterns and that aren't always obvious. And again, look through it, analyze, spit out or give you a spreadsheet with what you need to look at, and based on that, decisions can be made for your business. All right, and next we got pattern identification. Again, when you're looking at these spreadsheets that have 20, 30, 40 lines of columns of data, it's difficult to go through and see what patterns there are between different data points or spreadsheet lines, however you want to look at it. So machine learning is very good at finding those patterns and showing them to you and you can display in whatever format's needed. So we've seen some success with this with anomaly detection and payroll, and I'll go over that a little bit later. But what's going on there is we're looking for a file before it goes through any sort of processing, and we can identify which rows make sense based on other rows, so we're grouping them together, and the ones that don't quite fit into the pattern of don't quite fit into the patterns that are identified need to be reviewed. So yeah, machine learning does that really quickly instead of having a person look at these for hours on end. And next, we're going to go over some examples. I will pass it on to Austin to go over our first example.
Great. Thank you, Jesus. We really wanted to kind of go through, now that we've kind of established the four kind of main points of triggers that you might be able to look for in a project that would make it suitable for AI. We wanted to kind of walk through some examples of, what an example scenario was, how we identified that AI was the best solution for it, and then how we actually moved forward and implemented it. So Moss Adams owns and operates what's called the claims audit tool, which is used in the healthcare space and allows insurance companies to perform audits on claims that come in from hospitals. So they're responsible for identifying any errors that come up on those claims from the hospitals and sending them back to corrections and stuff like that. So there's a whole manual process of auditors that go through and audit these claims. And so some of that scenario is, these insurance payers face, high volume claims. And so like on a given day, there may be thousands or 10,000s of claims that come in from the hospitals that they service. And so that was kind of the first key indicator. We said, oh, there's high volume here, so there's a lot that's going on. And so, this is maybe the first indicator, the light that went off in our head that said, okay, maybe AI is applicable here. The second one was when we actually took a look at the auditing process. The audit process that these auditors went through was a very time-consuming one. Again, a very clear indicator that came off in our heads that said, maybe there's another option here. And so we have just observed in these data sets that we were looking at that, there's roughly 2 to 6% error rates. So out of 100 claims, you may have found 2 to 6 errors. And I'll talk a little bit more on that in the next slide. But, so we kind of set off to say, by leveraging machine learning, can we enable auditors to be more efficient with identifying these errors and anomalies? So maybe instead of finding only 2 to 6%, they're finding upwards of 40% per chats. So again, kind of just highlighting the issues real clear here. We've got large volumes of claims. We've got limited auditor capacity. And, these teams sometimes are often regulated by a minimum size required by federal laws. And so sometimes, there's only a certain amount of time that the auditors can spend going through claims before they have to either approve or deny them. And so these audits are time consuming. They're sometimes error prone. And, there's any delays or errors in this process can lead to increased operational costs. So again, high error rates and all of these issues kind of came together, and we said, okay, there's enough here that seemed like AI and machine learning might have a good place to be. So what was the actual machine learning implementation that we had? So we used a supervised machine learning model. So if you recall back to some of the earlier slides, a supervised machine learning model is one where you're using historical data to train a model that can predict on new and future data. So we had historical claims for these insurance companies that said, a given claim will have an error or no error. And, we can use that as our historical bank. And when we go through the training process, we can split that out and say, let's try and find where these errors are happening within, this 100-column row data set, for example. Once that training was complete, we were able to then verify on new claims that came in and say, can we predict these errors are happening or not? And so with that, we were essentially able to label, incoming errors for these auditors. So the actual implementation that allows these auditors to be more efficient is, when they first, instead of maybe trying to do a random sample of the claims that they have in a given day, and trying to say like, okay, let's just try and find a needle in the haystack here. We're actually trying to narrow down which records for these auditors to look at. And so with that, we kind of saw that these auditors with this kind of technology are seeing kind of a 20 times gain in the amount of efficiency. Instead of looking at 100 records and only finding 2 to 6 errors, they may be looking at 100 records and finding 40 or 60 errors. So it's really just leading them towards exactly what they need to be doing. So they're spending more of their time actually, correcting errors opposed to correcting things that aren't errors. So again, there's a 60% roughly model accuracy for this, and that's something that varies depending on the data and varies depending on a bunch of other factors. And there's an asterisk there that in the data science world, there's different metrics for accuracy. So there's just an asterisk to point that out. But so it was very clear benefits that we saw and very clear gains that this tool is able to gain. So next, I'm going to pass it over to Jesus to talk a little bit more about another example around the HR space.
All right, thank you, Austin. So like I mentioned before, most of my experiences have been in the equity compensation space or stock compensation space. I'm going to give a really quick primer on that. So sometimes companies will give their employees stock as a form of compensation, same way as a paycheck, but instead of a paycheck, it's stock. And similar to a paycheck, at the time you receive that stock, you're going to get taxed on it. So there's the ecosystem, the technological ecosystems for these systems are different by every company, but it's generally one system that tracks the stock compensation, one system for payroll, and then one for HR. And that's talking in general terms. It varies greatly by company, but you got data feeds going between these systems. So a huge part of what these people in HR do is they need to make sure that the data is accurate with all systems. And sometimes accurate for one system doesn't necessarily translate to accurate for another system, just because of the data formats that are required by each system. So the scenario that we've worked out is some company is giving stock to their employees. So again, like I mentioned before, at the time that they receive the stock, it triggers a tax liability. The employee has to pay taxes on that stock. They can sometimes choose to pay those taxes by either selling some of that stock on the open market, or the company will keep some of the shares and pay the taxes for them. But like I mentioned before, there's different systems that interact to ensure those records are accurate. And with manual data entry, human errors a possibility. So there's a ton of different fields that could influence the taxes and the stock. Any of those fields can impact the taxes for the participant. And some of those are like the termination date. If a termination date isn't entered on time, a participant could receive shares they're not entitled to. If the hire date is incorrect, it could throw off when the participant receives those shares. State tax rates, or any federal tax, really any tax rate at all. If there's a special case there and a tax rate has to be manually entered, there's a risk there that it's not entered correctly. And again, that translates down to the participant either paying too much or not paying enough taxes. So when that happens, excuse me, the participant either has to pay more taxes and sell more shares on the open market, or give up more shares to the company. It's not a good employee experience, and I can't imagine any scenario where an employee would be happy about him being in that situation. The flip side to that is too many taxes are withheld, and then shares or more money are owed to the participant, depending on this. And because of some of the sides of these awards, it's a significant amount of stock. It could range anywhere from $10,000 to $30,000 in having to buy back the stock, and then any penalties if depending on tax rules in the area. All right, so now you've got that primer. So what we did to kind of solve this problem is we used unsupervised machine learning. And just a quick reminder, unsupervised means we don't know whether a record is erroneous or not. The algorithm is just going to try to clump the data together into different groups, and we look at the similarities between the groups. So in this example, this is what one of the graphs would look like as part of the outputs. And on a payroll file, there's any amount of columns on the file. So again, I mentioned like state tax rates, there's multiple columns for that. Federal tax rates, any demographic information. Again, 20, 30, 40 columns, depending on the format of the file. This graph is much more simple than that. It is your XY graph from geometry class back in middle school. So what's going on here, just quickly, is part of what the machine learning algorithm will do is it will take those variables and break them down into mathematical components that can be plotted on an XY graph. That's the quickest. I'm massively oversimplifying that, so just take my word for it kind of at this point. But the point is once it's broken down into those two components that could be graphed, it's going to clump them together and cluster the data points together. And from there, we can see that there's this big cluster in the middle, and then all these points outside that don't quite fit in. And those points that don't quite fit in are the possible anomalies that could be violating, not violating, but that could have some error in the data there. So again, this is done at the time you receive that pair file. It's before any processing has been done and before shares have been awarded to the participant. So you catch the error in advance instead of fixing the error after the fact. The other cool thing about an algorithm like this is there's some errors that we know are going to happen, and we can set up business rules to catch them in whatever system you have. Usually equity systems can do this. So this helps you find errors that don't have business rules established yet. So yeah, it excuse me. Yeah, it helps find errors in advance, and it helps you be proactive instead of reactive to some of this possible errors. All right, and next we have benefits. So again, like I mentioned before, the big benefits of some of these this case was that we were able to find some of these errors before they happened. So there's no downstream impact. We kind of prevented it in advance. This kind of analysis is done on one data set. It doesn't learn. Can the slide be seen? Hold on, let me see. I think the slide got stuck. Oh, okay. Thank you, Chad. Okay. So yeah, the analysis for these are relatively low effort and cost once you have the knowledge to do that. Again, these are done on one data set. It's a snapshot in time, so the analysis can be done pretty quickly. And again, it helps you catch errors that you don't know are possibilities yet. So there's a lot of value add there in catching the error in advance and being proactive as opposed to being reactive. Okay. All right, and next we're going to move on to our next polling question. Did this presentation spark any ideas for possible AI projects in your business?
Yeah, and while we're waiting, Jesus, thanks for that presentation. I had to laugh at the graph because I was an econ major and spend lots of time looking at graphs. And every time I look at that two-dimensional graph, I'm looking at the X and Y axis and saying, what is going on here? Show me what you're saying in the outlier analysis. And the reality is that machine learning is taking 50, 60 variables and representing them in a two-dimensional graph. And so yeah, I really laugh when you said trust the math here. Just trust me with these are outliers. But so these are kind of things where the math is so complex and the tools are so powerful that it does more than at least my mind can handle. And but it does call out outliers, right? And so what I'm so excited about is the fact that we can now use machine learning in situations where, in the Stockholm world, and I'm also in the Stockholm world with Jesus, we see, errors creating significant downstream consequences. And with thousands of employees receiving grants and, big time event, like one-time vesting events that happen 2 or so times a year, errors happen and they create tons of work for people downstream. And so what we're seeing is that these tools can actually prevent or at least identify potential errors out of, like finding a needle in a haystack. It can find the 3 grants that were for executives that were, high levels of compensation that you may have already been reviewing as a stock comp administrator, but maybe not. And so it would highlight those as, hey, these are anomalies, they're very large grants. And so you could review them as part of a workflow and potentially detect an error in it. Now, sure, there's going to be false positives there where it thinks it's an outlier and it's nothing wrong with it. But at least as a stock plan administrator, knowing that you looked at the ones that the AI thought may have an issue out of a whole sea of grants, it really highly optimizes the efficiency of individual review before a major vesting event. So we're pretty excited about seeing this coming alive, because I can envision a time where every pre-vesting that happens, you run an AI model on it, and outcome, you can just set however many you want to look at. Here come 100 grants out of the AI model. And these are the ones that maybe have errors, maybe not, but at least you're looking at the ones that the AI thought are most likely to have an error. And I think that's fascinating, and it is going to be probably a game changer in terms of efficiency and reducing errors down line. And we'll be presenting on this more in the fall at the NASP chapter meeting with NVIDIA, Microsoft, and Amazon. So I'm really looking forward to seeing how large companies at scale are going to be doing these error detections. So now we can kind of go to the polling question. And I went too far, sorry about that. Good. We've got at least some. Not sure about next steps, and definitely great to see the yes 33%. So that was exactly the purpose here, that it shakes a little bit of the mind space on how AI can be applicable for you. And that's great to see that we achieve some of that goal. And we can go on to the next slide unless there are any other comments here. All right. So business considerations, I'll just start here. I've got the middle 2 bullets here that I'm covering, which are kind of how do you get involved in AI and the considerations around investment. And I mentioned some very large companies that we're working with. It's been amazing to me to see that even companies that really specialize in AI type services have not yet set aside sufficient budgets and time and resources to consider how AI can be applicable in their particular business unit. And so as probably the most important thing you can do is set aside some time and resources and money. These can be expensive, but what we found is that proof of concepts, you can fail fast and prove that it's going to either be fruitful or not. Like the example I talked about with a trucking company, that was a very low cost, and you can see that it would work. So making sure that as you plan your budgets into the future, you're carving out some time and resources to take a look at it. And I think it's really important because almost every company has some interest in doing this, and a few will succeed in that and will have a competitive advantage. And so this is pretty important for long-term success of companies, is to make sure that they're thinking about how AI can change it and looking into it. The other point is that while these tools are becoming more and more prolific, and frankly, lots of data scientists coming out of school now, there's lots of capabilities out there in this space. But picking the right technology and applying the business context to it are subject matter specializations that would warrant some, probably some additional advice in proof of concepts or setting it up or strategy work. So those are 2 items I think are really relevant. I could turn over to you, Jesus, to speak on your topics.
Yes. So I wanted to talk about data privacy. And we're collecting a lot of data to put through these models, and it's important that the data is safeguarded. There's that issue recently with the car dealerships and the ransomware where it shut down, I forget what the percentage was of all the car dealerships. Depending on the nature of your model, you might not have that impact, but it's still something to consider, something to work with your cybersecurity teams, just because it's a real concern. It's not a matter of if, it's a matter of when your data is going to be compromised. So it's important to have those safeguards when you're collecting all this data for your models, and then also the storage of your models. Where are you going to put them, where are you going to put them to run them, and all of that case. Again, it's just better than safe than sorry when it comes to data privacy these days. Next, the models, going back to that graph where I kind of told everyone, hey, trust me with the math. Some of these models are subject to regulation, and just trust me with the math is not an acceptable answer for a regulating body. So depending what your model is used for, if it's subject to regulation, it would be better to have a model that's not as good but is explainable, as opposed to a model that works great but you can't really explain what's working under the hood. So usually with something like regression models, they're really easy to explain. It's an equation. You see the impact of each variable on the end result. But with something like clustering, it's a little bit more difficult to explain. And if we move past it to even neural networks, it's even more of a black box. So explainability without having that knowledge is almost zero. So just something to consider when you're creating these models. Double check to see if you're subject to any regulation, and if so, make sure that you're working with your teams to make sure that your models can be explained. So yeah, and with that, I will pass it on to Austin to wrap up this slide.
Yeah, thanks, Jesus. So the one other key point that I really wanted to get across here is that machine learning is really the last like 10% of any business problem. I think getting good data and having good infrastructure is probably the first 70-80%, and then data analysis maybe is the next 10%, and then really AI, machine learning, and everything on top of that is really the last 10% of any business problem. And so it's really important that that last 10% really gets integrated effectively into the workflow of your business. So it's really crucial that we don't want AI to come in and just say, oh, let's upend everything and start fresh and get a new slate and have a new process for everything. We really believe it's important that there's a really niche spot for AI in every business, and just figuring out where that spot is almost a lot of times a lot of the problem, or a lot of the problem that we want to solve. And so just wanted to call that out. And then obviously, with any type of thing, there's always risk of returning false positives or false answers when you're dealing with AI. So then again, there's metrics that we can use to deal with some of that, and we can know what that risk is associated with every model that gets trained. So that's going to wrap up our business considerations. I know we have a couple more minutes here, and so if anyone has questions, feel free to put them in the Q&A section, and I'll be able to get back to you all with any questions or any answers to those questions. But real quick, I just wanted to highlight one question that did come in during our session here, which came from someone that asks, what is the acceptable model accuracy when it comes to machine learning? And that was a great question. I thought, I really wanted to highlight that because it often depends on the business context. In the medical field, you might need, when you're dealing with someone's life, you're going to need a 99% accuracy rate. But maybe in a retail setting, even a model with 40% accuracy is something that could provide value and cost savings or whatever it is you're trying to accomplish. So a lot of times accuracy is not necessarily like a great metric, because a lot of times it depends on what the context around that is. Yeah, feel free to post any more questions, and we'll get those answered for you, and we'll be following up. So with that, I'll hand it back over to Chad to wrap up our session here.
I just want to make one final comment, Austin, that a very smart partner that I work with suggested, as he's been also investigating AI alongside us, that machine learning and AI can be seen as driving a vehicle or an assistant in driving the vehicle. And what we've done in the past, we often look at like the error rates, we look at things that happened in the past, and we try to fix what's going on in the future. And that works pretty well. We have lots of business rules in our systems that we've designed, and they catch many of the errors. But when you think about driving a car, that's like looking in the rear view mirror to drive along. You're like looking in the rear view mirror, the kinds of errors that you've seen in the past, and making sure those don't happen again. But you're not thinking at all about the errors that you've never detected that might be out there about to come. And certainly in the HR space, when a new business unit comes online, or there's some fat finger that adjusts a state incorrectly in the underlying data, there's no business rule that's going to catch that. And so then it gets all the way through, and there's some consequence down the line. So what we're seeing is that the AI tools that are out there now are like making decisions looking through the windshield, like you're driving, and the AI is out there looking ahead and scanning for you and popping back some things you ought to take a look at. It may be a false positive, it may not. So that accuracy question, I'd be fine even if if I'm looking at 100 grants and I find one major error out of that 100, I'd be fine with a 10% accuracy rate, and that kind of thing, because I'm going to spend some time and I'm going to review what's about to happen ahead of me. And if I find any few errors out of it, that was time well spent. And so I think it's a very good question about accuracy, but the business context and how it's being used is also very relevant. So we can wrap it up now, Chad. Thanks so much.
All right. Thank you, Matt, Jesus, and Austin, for a great presentation today. If we didn't have time to answer your questions, we will do our best to follow up with you after the webcast. Here's a link to an online survey where you can provide feedback for today's presentation. Please take a moment to complete the survey, as your feedback is very important to us. Thank you for joining us today, and we hope you join us again next time.